Hey, Jenny here, and I'm pleased to be visiting today with Dr. Alexandra Belayew. How do you see the next few years shaping up in FSHD? What do you think are the most important things that need to be accomplished?
What I think is really lagging behind is children FSHD, so infantile FSHD. And that's a major problem because whenever a drug is developed, it will in priority be developed for adults, except for Duchenne, because in Duchenne, children are sick. So, but for the other pathologies, people are mostly focusing on adults. And because the disorder is progressing much faster in children, I think it's really important to think about them.
Right.
Now, the second thing is we still have not understood everything that DUX4 is doing. Why our muscles destroying themselves. And we have, of course, this induction of apoptosis that is triggered by DUX4. But DUX4 is produced in only very small number of cells, and the muscles are made by the fusion of many cells. So one muscle fiber is like a giant cell with many nuclei of the cells that fused to make it. And so when you look at these nuclei, it's only about 1 in 200 that is producing DUX4, that is activating the DUX4 gene. And so how can such a small amount of toxic protein really cause havoc over the whole muscle? Well, of course, the disease is progressing slowly in most people, but it's still progressing. So it's not clear yet what's going on exactly there. And then the third thing that I think is very interesting is now this discovery that DUX4 can be produced in cells of the immune system, like in lymphocytes. When you have the muscle starts being killed, you have inflammation that is occurring. So you have cells of the immune system that come in the muscle, and those cells are producing DUX4. And so this is something very new, a very new concept that has been found by the group of Peter Zammit and his very bright researcher, Chris Banerjee in London. And so I think we are at the beginning of a new field of investigation for DUX4. What is DUX4 doing in lymphocytes? Do we need to shut it off in lymphocytes as well as in muscle? It's something that will have to be investigated, which I think is very, very interesting.
Intriguing, isn't it?
Yeah. And also what I think is that, for children who are affected with Duchenne muscular dystrophy, they are given sort of a background basic treatment, which is they receive glucocorticoids. And these drugs are slowing down disease progression. And this is now given systematically to all kids with Duchenne. And what I believe is that we should come to something similar with antioxidants with patients who have FSHD, like they have done in Montpellier in France, so the group of Dalila Laouch. They have done a clinical trial, but they keep giving the antioxidant complements to patients. So some patients have been on these complements for now 3 to 4 years, and they're pretty happy with that. They say that they feel less tired, the disease has slowed down, some of them have even regained muscle function. And I think it's something very interesting there, because there's a Japanese researcher who is himself a patient with FSHD, Dr. Sasaki Honda, has found that oxidative stress could activate DUX4 production. So we probably have some kind of vicious circle there. Oxidative stress activates DUX4. DUX4 decreases the ability of cells to fight oxidative stress. So oxidative stress is increasing and increasing the amount of DUX4 and so on. And so I think that by decreasing oxidative stress with things like what the group of Montpellier is doing, will help also decrease DUX4. So it has not been demonstrated, but it's my vision of what's happening there that probably has to be taken into account. And so my idea is, okay, maybe with anti-oxidative stress complementation, you can slow down disease progression and people can wait for the miracle drug that will really cure them.
Right.
And so I think well, more research is ongoing in that direction, I think. And now on the therapeutic part, you have all those bright people coming with all ideas of various drugs, like the virus that is developed by Scott Harper's lab. Looks very interesting. In his group, I think they have 3 different strategies to go kill DUX4, which are all smarter than each than the other. And so, well, you need several years before it's actually to be tried, but I think that there's very good hope there. So if our antisense oligos are not the cure, it's no problem, because the target has been set and now many other people are coming with different strategies. And they were like, I don't know, like 10 different strategies mentioned at this FSH Society meeting. And certainly a few of them will be actually working.
Right.
And so I think that there's really hope for that. And also the strategies to help muscle regenerate. With this discovery for many years, people thought FSHD muscle could not regenerate. But a recent publication from Chris Banerjee and Peter Zamit, again, the London guys, has shown that you can detect regenerating fibers in FSHD muscles. There are very few of them, but they are there. They obviously cannot, fight against the destruction caused by DUX4. They are not enough regenerating fibers to compensate for the cells, the fibers that are dying, but at least some are there. And so you could boost them. And that's also very good news. So you might, on the one hand, prevent DUX4 from being toxic, and on the other hand, help the muscle to regenerate. And that would be the perfect cocktail, I think.
That's right. And, we have CRISPR inhibition too, that the Jones lab is working on, and all kinds of exciting things that all these brilliant researchers are putting together. Like you said, there's so many things going on now that even a few years weren't occurring. So that's exciting news for you, for other researchers, for patients.
Yeah. It's of course always very slow, but okay, we're coming there. Remember how it was like 15 years ago. There was no hope.
Yeah. That's right. Exactly.